Episode number 7 of the C11 tutorial where I am building CKong, which is a replication of the arcade Donkey Kong game from, I believe, 1981, 1982, something like that. In episode 6, I was a little bit stymied because it turned out that my Rust-based tile ripping program had a bug in it. Now, I actually fixed the bug. There were 2 bugs, and they were small. I'm not going to go into a great deal of Rust, other than to kind of explain that this is a command line program. We have a main function, and we get the arguments from the command line, and then I determine what mode the tool is going to run in, and then finally I get the path to the bitmap that we're going to parse, and I pass that to my run method. And then in the run method, we have a case here and a match, which is pretty much like a switch statement in C, where we do our sprite ripping. And everything here was correct except this, because there's 67 tiles on a line, and my for loop here was not going far enough. And then the other mistake I made was the break statement I had was checking for 96, which was 96 is the number of sprites that can be on the screen at one time, not the total number of sprites in the data. 127 is actually the upper bound for the number of sprites in the data. So after I fixed that, I was able to run, I might still have, so it would be cargo, run, bin, ripper, and then the arguments for the ripper are sprite and then assets Donkey Kong sprites PNG. And so if I run that, then the ripper program actually loads the tile set into memory, and then what it does is it generates text that it just writes to standard out. Now this is actually generating Rust source code because this was intended to be pasted into Rust code. So what I do is I copy and paste this into C, and I do some regular expression replace, copy, replace. But with those changes, the tile ripper actually successfully gets all the tiles, and it gets them in the correct spot. So now if we load up CKong and we go to sprite.c, now we actually have the updated tile set data. So you can see that sprite 126 actually has some data in it, right? Instead of just zeros, there's actually pixels in here, which is what we want. And so I updated the tile numbers in some of our actor definitions to be the right ones now. So I'm actually just running this, and the first time through it takes the debugger a little bit of time to get going. And so there you go. So we actually have all 4 frames of the fire animation now. And if I run this again, and then you can actually see the score. Now that shows up correctly. So that's good news. We've got the right sprite tiles, and so we can actually continue on with what originally we were going to do last time. So let's go back to that. So we can do all the different scores now. So you saw 100. So we can actually do 2, 3, 5, and 8. Those should be really easy. And, you know, I'm going to actually, I think it'd be kind of cool if we did a little bit of X and Y movement too. So I'm just going to test that real quick. Yeah, see? So now it kind of just floats. So I think that's a neat little change. You got to imagine that back when they first made this game, back in the, probably they started in the late 70s. I'd have to look at the history. but they had very minimal amount of memory, and most likely all of this was coded. So this is going to be tile 124 for 200. And then we need to change our function here so that we return the right animation. And then let's do 300, 500, and 800. And as you can see, once we get the basics in place for these, a lot of these become just cut and paste and minor edits. Okay, so that's 300. And did I change the name properly? I did. Okay. This is a 500. Okay, so let's make sure that compiles. Now, let's go on to Pauline. Let's put her up there. So Pauline standing right. And her tile is going to be so Mario's jump is tile 14, 15, 16, and 17. So Pauline is actually a 2-tile actor. So we're going to make this -16, and we're going to make her feet the origin point. And I'm not sure which palette is the right one, so we'll figure that out. So let's add her. So S Pauline actor, and yeah, I think these are all reasonable defaults, and then we'll put her in the list. And then we need to bring up the state machine, and we need to grab yep, and we're missing that, so let's And on the animation side, we need to make sure we pass in the right, or pass back the right and Pauline standing left is going to be you can just copy the standing right animation. And then this is just a horizontal flip. Like that. Okay, so let's make sure that, oh yeah, we didn't do anything to it. So let's do that. Let's make sure that we turn the actor on, for one. And let's set the X position, that one is Pauline, to, let's see, 13 times 8, 104. About 40, I'm gonna guess. And let's call actor animation, passing in Pauline, and we'll set this to anim Pauline stand right. And we enable the actor, and let's see what that looks like. Oh wow, I almost got the positioning 100% right. It's close. Now, we'll notice that the text that we're putting on the background is off. It's in the wrong spot. So Pauline needs to stand a little bit down, and I don't think we have the right palette selected. So we'll have to double check on that. Okay, and then I think our tiles have to be moved over a little bit. But first, let's get Pauline. So let's fix the Y position. That's a little too much. Okay, so she's standing on the platform in this case. And then our help text just needs to move over on the in the grid. I believe I'm doing that here. So instead of 14, maybe 15. And we'll change the blink as well. Yep. There you go. And I don't know, I mean, we'd have to look at the actual game itself again here to see if I've got that kind of aligned properly. So she actually has like a pink dress, and her boots are blue, and her skin is white. And the text color is actually cyan. So alignment-wise, we have the right thing. So the help text is in the right spot. And she does a little dance, which is a 2-tile dance on the lower tile. Okay, so let's try to figure out which palette is the right palette for one. And then we had to change the palette on the help text too. So the help text should be palette. Well, let's bring up the palette bitmap. Okay, so here's our palette reference. And we know that we want the text to be cyan. So I'm almost wondering if this should be just palette 0. So let's see what that looks like. No, that's not right. So that's red. So, okay, so it has to be a palette where the cyan color is the fourth color in the palette. Yeah, so that would be palette 4, 5, 6, 7, it looks like is the right one. No, am I one off? I think I might be one off. Yep, okay. So now that the help is showing up in cyan color, so now we need to find a palette where, I'm guessing this is color number 3, or index 3. So we need to find one where that's 6, 7, 8, 9. Palette 9 is what I think we're looking at for her. So if we go back to our actor definition, oops. So I believe we're looking at palette 9 for her. Oops, not Mario. Okay. Yep. I think that's, well, no, that's off just a bit. So palette number 9. I think it's palette number 10, actually. Oh, and it might be, okay, hold on. So I think the upper is palette number 9. The lower, I think, is palette number 10. Let's take a look at that. Yep, there we go. So we have the golden hair, the white skin, the cyan for the dress, and then for the bottom we have the blue sash, the white for the trim, and then the blue boots. That's the coloring. So it's actually 2 different palettes, one for each tile. So this is 9 and 10 the other way. And then we have the, we want to make her dance, right? So that's just a 2 frame on the bottom, actually. Or did I call it shuffle? I think I called it shuffle. Yeah, Pauline shuffle. And we'll change the name. We'll have 2 of these in case we need them. Okay, so this is going to be 2 frames. The top tile stays the same, the bottom tile changes. And the delay I don't know, let's do 100 milliseconds on each frame delay, and shuffling left is exactly the same thing, we just have the sprite flip. Okay, shuffle left, stand right, stand left. And then we have in our animation access, we can access those. And okay, so what we'll do to test that is in the state machine, we'll just set her animation, Pauline, shuffle right, just to see that that works. Oops. Looks like I missed a comma or something. Yeah. Oh, I copied the wrong thing. My bad. There we go. There she goes. And she does a little shuffle. So, but that's a bit fast. It wasn't going that fast in the arcade. So let's slow it down. Let's make it 133 milliseconds between each one of these. Okay. That's closer. There you go. Now that's not how the arcade does it though, right? She shuffles while the help text is up. So this, and the help text is only up long enough for her to do the animation cycle essentially a couple times, and then it goes away. So what we need to do is we need to add the same functionality that we added for sprites, for actors, that callback. We need to add that for the background blink timer. So if we go to the video header file and we look at our background control block, we have, these are the fields that I added for controlling the blink. And what we need here is we need a callback that can be set. So let's take a look at actor header file. And we're gonna type def this. Now, the trick is, though, we don't want to get a callback for every single tile. We just want to get a callback for one of them. So let's call this BG block blink callback. We'll pass a BG control block T pointer to it. And we'll return true or false. If we return false, then it stops the blinking. Yeah. Because, well, let's not stop the blinking. Yeah, how are we going to do that? So what we have to do, we need to know the range, right? We need to know what. Well, okay, but let's think about this. So we're going to set the callback where we've initialized it, right? So in other words, we're going to set yeah, so that's what we should probably do. So how can we do this? So when we set the blink, let's take a look at what this is doing. This is just looping over the blocks in the control table for the background, and it's setting the blink visible, blink duration, blink timeout. Okay, so instead of, because what we really would like to do is we would like to know the range. When we add a blink, we would like to have that be kind of its own data structure. So let's do that. Let's make a new structure, BG blink T, and it's going to have a rect in it. And it's going to have the blink flag on it. It's going to have the timeout and the duration. Well, it helps if I type it right. And then it's going to have the callback. Okay, so then what does how many blinks do we need? It's kind of funny. How many blinks do we need? So let's say that we can do max blinks. Let's say we can do 16 of them, which is way more than we would ever need for this game. So this is going to be BG blink T S blinks blinks max. Let's be consistent with our naming. Okay, so now we have a static array of blinks, and internally we have to keep track of which blink we're on as we add them, right? So so then what this means is we can take this out of the background control block, which actually that makes me happy a little bit, because that takes out some repetitive data that we really probably didn't want to have in there anyway. We need to rewrite this, so we're going to come back to that in a sec, and we need to change this, because we're not going to be changing the background blocks anymore. Okay, so when we do a new blink, what we're going to do, bg blink, we're going to returning back a bg blink t pointer. Okay, so we know what our current blink is. So we're going to say bg blink t blinker is s bg or s blinks sub s current blink, and then we're going to add to that, and we need the address here because these are our stack things. We need to get the address of it, and then we're going to return back that blinker. So now we have a pointer to the blinker structure, the blinker data structure, when we add it. So that means if we go to level C now, this we have a bg blink t pointer, and this is really the help blinker. Okay, and this is going to come in handy now when we get our callbacks. So now, so we've restructured this. How is this going to actually work now? So the blinker itself is pretty simple, right? So the blinker, oops, we're going to set the bounds to be a new rectangle. Oh, can't do that there. I think I can initialize it here though. So left is equal to X, top is equal to Y, width is equal to width, height is equal to height. And so we set the bounds, we set the duration, and then we set the timeout the way we were before. So it's going to be ticks plus duration. And then if we have a callback, so now we need to add in the callback. So we had bg block blink callback. So let's just actually call this bg blink callback. Let's be consistent. And we need to change the prototype. Oops. Okay. And we set the callback. So that's what happens, and we don't need to loop over the we don't need to loop anymore. Right? Almost forgot that one. So now we're just creating one thing instead of touching n things, which is always good. We should assert here that sCurrentBlink is less than blink max. Because if we're using more than that, then the easy answer is just to change the max, right? If we need more than 16, we can have more than 16. Okay, so now, if we do a video reset, then what we should do is change sCurrentBlink to be 0. And, right, because if we call this, we're resetting the background, so the behavior, we want any blinks that were active to be gone. We don't care about those anymore. Now, the downside with what we've got now is we do have to, we can't just check the blocks as we're rendering them. Now we actually have to loop over the number of blinks that we have that are active, right? So here we're going to have to say uint32t b, do I have, well, I don't think I have a j. We'll use j. I like ij. So j is less than sCurrentBlink, right? So sCurrentBlink is going to be 0 to start. So if we have no blinks, nothing happens here. If we have some, we're going to loop over this that many times. And then we're going to get the we're going to get a pointer to that blink. So bg blink t and we're going to check. So first, there may be a blinker there, but is the duration greater than 0? So we might want to have one in there, but we might temporarily want to have it cut off. So if it's cut off, we don't want to now I think we can refactor most of this. So if we have a duration on the blinker, if the ticks is greater than the timeout, now we have to do some, we have to change the way this works. Okay. So here's what we have to do now. If you remember that for loop that we had in video, I'm going to use the diff so that we can see what code I had before. So what I'm going to do is I'm going to copy this code. Actually, I have to do it using the keyboard. So copy that. Okay, so what we're going to do here is we're going to say blinker bounds left, or I'm sorry, top, blinker bounds left, and this is going to be bybx, and this is going to be bi and this is going to be bj. So this is actually height. This is width. And what we can do, this doesn't have to happen. This happens here, right? So before we go through the tile map, we go through the blinkers, then we determine if anything has to blink. What is the type? int16t. Okay, so let's go back to our, let's make these int, there we go. And so actually I can make this I. Okay, so that's I. That's the doorbell. Okay, so what we're going to do, how this should work is okay, so we get the ticks, we loop through the blinkers that we have. We get a pointer to the blinker, and if the blinker duration is set, then it's a valid blinker right now, it's enabled. Then we check to see if the current ticks is greater than the timeout that we set for the blinker. If it is, we set the new timeout for the blinker, and we toggle the visibility on the blinker. Then we have the loop that used to be in the code that was VG, or video blinker, video BG blinker, the thing that would set the blinker. Because now we're not changing the blocks, we're actually creating a parallel structure that tracks the blinking. So we only have one of those per blinker, even though the blinker might cover a range of tiles. So what we have to do here is we have to update the range of tiles appropriately. So we get a local variable for the Y and the X. We loop over the size, the height of the blinker region and the width of the blinker region. And so actually, we can use our txty thing here, and we can just make this Y and X, because now they're outside of that. So this should be ty plus y and tx plus x. There we go. Okay. So now we get the start upper left corner of the bounds for the rectangle that we're going to modify. We loop through the height, we loop through the width, we grab the block at that position in the map. If the blinker is off, then we disable that block. If the blinker is on, we enable that block. We set the change flag on the block, and we go until we hit the right-hand edge. So if we hit the right-hand edge, then we wrap over to the left of the block, and then we keep going, same thing. We only increase Y for as long as we're within the bounds of the map. So that means if you specify a range on the edge of the map that extends past the map or below the bottom of the map, then this will clip essentially on those boundaries. And then what we want to know is so if we've timed out, if there's a callback, so if blinker callback is not null, then we want to call it passing in the blinker pointer that we have. And so here, if So if there's no callback, then we just manage the blinker state, the timeout stuff on our own. If there is a blinker callback, then we only want to do that if, so there's got to be let me restructure this. So if blinker result, then we're going to do this stuff here. So how does this work? So basically, we set the default value for the result to true. If we have a callback, we call it. The callback's going to return true or false. If it returns false, then the callback did something to the timer data, and we don't want this code to do anything else to it. If it returns true, then that means we want the default behavior to continue. So then the default behavior is to set the timeout to the next timeout and to set the visible flag based on the standard toggle. And I'm thinking maybe we just always want the visible flag to toggle. That's okay. And what this will let us do, this will let us change the duration. So if we change the duration and we return true, then the new duration is going to be the one that comes into play, and we can change it at each time however we see fit. And then what we should do okay, we probably should put on our blinker let's put a couple user data fields so we have some place to put some state. Okay. So I think we got everything refactored for that. We added in blinks max. We added in the BG blink structure. We took the blink data out of the control blocks. And so when we have a callback now on the blinker, and we have the bounds of it, whether it's visible or not, the timeout, the duration, and some user data. And we changed our video BG blink, returns back a pointer to the blinker that gets created. And we can also now specify the callback. And if we don't have one, it's null is a valid value. That's what we would pass in there. And then in the video module, we have a static array of blinkers. Let's actually rename that, and then this should be blinkers max. There we go. Now they're called blinkers. All right, that's better. All right, so this one we don't need a callback, so we can just pass null. That's fine. Okay. So now it's not gonna blink. Would be meaning I think we need to extend the background update. Yeah. So we need to extend the background update because now we need to handle the fact that it's enabled or disabled. So if we look at video, what we're missing here is if the tile is disabled, what do we do? What does that mean? And right now, it doesn't mean anything. We're skipping over stuff. So what we could do is set tile index to 0x0a and palette index to 0x0f and give that a shot. So if it's disabled, what that means is you get a black blank tile. And if we look, that's a little closer to what we wanted. It looks like we're missing one though. Yep, looks like we're missing one. I'm not quite sure why that is. So I think I know why. Maybe. Video BG blink. So our bounds is top 0, left 5, width 3, height 1. Duration, timeout, callback. Callback is null in this case. Didn't mean to do that. All right. Wrong keystroke. Okay, so our current blinker is 2. Okay, so we grab the first blinker. This is the one for the 1-up, I believe. So, yeah, this is the one for the 1-up. So did it time out? Yep, okay. We didn't have a callback, so we're going to go ahead and set our new timeout. We're going to toggle the visible flag. Our TY is going to be the bounce top, and our TX is going to be the left. We're going to loop for the number, for the height, and for the width. And we're going to get the block. So our block here should be 0 and 5. We set it enabled. We set it to be changed. Right, we're okay. Yeah. Yeah, that was the, I think that was the bug there. Yep, there we go. So 1-up is blinking again. Help is blinking again, the way that it originally was, except now we have this parallel data structure that's tracking that, and it has callbacks. So now let's fix the help, and let's fix Pauline. So Pauline should only do her little dance when the help thing shows up. So first, let's go to the state machine, and let's change Pauline to just be anim Pauline stand right. And then what we're going to do is in level, which is where we were setting up that blinker, we're going to put some state here. So on help blinker in data 1, we're going to put the value of let's create some flags here. So enum help f help t and these would be like f help off and f help on. I don't know, do I need those? I'm thinking maybe I don't need those. Maybe. So here, when we get the callback, if the blinker is visible, then the duration is going to be, instead of 5,000 milliseconds, it's going to be like 1,000 milliseconds. And then here, we're going to get the actor for Pauline and we're going to set we're going to set it to shuffle right. And then if it's off, we're going to set the duration to 5 seconds. We always need a reference to Pauline, so we'll hoist that up. And this will be anim Pauline stand right. Okay, let's see how that works. Okay, so the help is, well, yeah, it's actually probably defaulted to on. Let's see what happens here. Okay, so it's actually inverted. Okay, so okay, so I think the reason for that is we're doing this in the wrong spot. Right, we should do that after. So it should update with whatever the state is, then change the blinker. Well, maybe not. There it goes. Okay. We need to have it though. There it goes. See, she does the dance now when the help text comes up, and the help text is only up long enough for her to dance a couple times. So it's closer. Okay. Okay, so that's the other issue. We got to go to video BG blink. This is our code that sets this up. And the mistake here is we need to explicitly set visible. Because again, this is C, right? So by not setting something, it's uninitialized. Or it's whatever the value was in the previous execution of it. Although we're still seeing the help, so... Right, so what we have to do, how are we going to do that? So here's the issue. The duration hasn't elapsed yet. So when we set the blinker, the text is enabled. We're seeing it. So there's a couple ways we could do that. Video BG stir. We could pass a flag in here, right, if we wanted this to be disabled by default. So in the case of help, we would like the text to show up or not be enabled by default. So we want to pass enabled here, or actually, I'm sorry, this we don't. We want to pass FBG none here. Here we want to pass enabled. This one should be enabled. Although this one does have a blinker on it, so we could decide like whether we want it to show, and then, you know, I mean, technically this should be none because it starts off as not visible. That's the state machine. Otherwise, if we don't do that, then the state machine, we're off a cycle, more or less. I mean, it'll catch up eventually, but okay, so no, it's still not. Okay. Ooh, yeah, okay. So that's... So really... I think that's what we want to do here. Okay. I've got a dead... For some reason that one won't die. So boy, it really doesn't want to go. boy. That's a resistant one. So I want, yeah, it was tied to the debugger, I think. That's what was doing it. All right. Okay. So now we don't have a zombie Donkey Kong process floating out there in memory. I changed the interface to be true or false because we just want to take the enabled flag off. And perfect. So now the help text does not show up initially, and it's synced up to the animation. The help text is now syncing the animation to Pauline, so she does that little dance. And so if we look at our game next to the original, there she does her little dance, and then ours does a little dance. So I would say the arcade actually probably does it a bit more than ours. Of course, he dies in the middle there. Oh, that was the attract mode. Yeah, it's about, I mean, it's about 5 seconds. Maybe it alternates a little on the arcade. But it's pretty close. Okay. So that's good. So we got that working. So we have callbacks on the blinking. We refactored how the blinking works. So the blinking is no longer tied to the blocks in the background itself. The blinking is this secondary structure, which actually ends up being much nicer because now the blinking data structure actually records the area that is blinking for us, and we have a callback on it, and we can now tie other behavior to the callback on that. We can change the duration of it, so we have a lot more control over that. All right. So let's review that. So in video, we added the blinkers max. We have up to 16 blinkers, which again, I think for this game is more than sufficient. We added our new blinker structure, and it has a rectangle on it, which is the bounds of what it's blinking in the background, whether it's visible or not. The timeout, so this is the next time that the blink state will change. Duration, this is the amount of time in between. So this is the relative value to add to the current time. This is the next time itself. Then we have some user data on here. And then we have our blinker callback, which returns a Boolean, and it accepts a BG blinker T pointer. We took the blinker state out of the background control blocks, which again, like I said, that makes me happy because it never really felt right for it to be there. And then video BG stir, we pass in a Boolean to make whether or not the tiles that we put text into should be marked as enabled or not. And then we can create a video blinker, right? So the change here was we pass in null if there's no callback or a callback. And we also get back a pointer to the blinker itself in case we want to change aspects of the blinker. And then in the video module, we have our static array of blinkers, so up to 16 of those. We have a variable sCurrent blinker, which is the index into the blinkers array and also doubles as the count, right? This is how many there are right now that are active or not active configured. Because active is whether or not the duration flag is 0. And then we have the Boolean flag on video BG stir. And all we do here is if it's not enabled, we just take the enabled flag off of the flags on the block. And then video BG blink, instead of this actually touching the blocks now, what this does is it goes out, gets a blinker from the static array of blinkers, gets the current ticks, sets the bound, sets the visible, sets the duration, callback, and sets the timeout. and then it returns that pointer. When we do a video reset background, it resets the current blinker index to 0. So the data is always there because it's static data on the stack. We're just indexing into it and reinitializing it as needed. And then we got to take out all the blink stuff for the blocks. And then in video background update, what we do now is we grab the current time and we loop through all of the blinkers and we apply the same logic. As this is now kind of a combination of the logic that used to be in the block loop and the VG, or the video BG blink function, because we have to go through now. If a blinker is making changes, we need to loop through the blocks in the map and actually update them at that moment. So this is before we go through the background control map to actually update it. So we're affecting the same kind of result. It's just that we're doing it all ahead of time in this one spot. And then of course the key functional change here was that if there's a callback, we call it, we get the result from the callback. If the callback returns false, then that means the callback took care of everything. And we don't want the standard timeout adjustment to apply here. If we return true, then we want it to go ahead and compute the next timeout for us. And so then the change here was we got rid of the loop that does the blinking here because we're doing it all above. And then if the enabled bit is off, now what we're doing is we're setting the tile and palette index to that black blank block, which gets us the same result as what we had before. And then we got rid of the blink related initialization code in video. And then in State Machine, we grab the Pauline actor and we position her on her platform and we have her standing right and we enable the actor. And then in player, we have to pass, some new parameters here. So we want the 1-up to be disabled or not visible by default because the blinker starts off in that state. And then the rest of these we want to show up right away. In a machine, same thing. We want the high score and the level to show up, or I'm sorry, the high score and the high score text and the high score value. We want those to show up. And then in level, this is where we were putting the blinking help, right, for Pauline. So we initially set the tiles that we print into the buffer as disabled. We set our blinker and we have a callback now, help blinker callback. And so whenever the blinker state changes, the callback is invoked. We grab the Pauline actor. If the blinker is visible, we set the duration of the blinker to only 1 second. We set the actor animation for Pauline to the shuffle, little dance that she does. And so what that's going to do is she's going to dance and the blinker, the help text will be on for about 1 second. Then when the timer trips again for the blinking text, we set the duration back to 5 seconds. So it's off for 5, on for 1, off for 5, on for 1. And we're going to set her animation back to stand. And yeah. And then in actor, we added the Pauline actor. We added the shuffle right and left. And yeah, so then we just, we fixed, so a little score thing, it goes back and forth. I did that. We added all the different bonus scores. And then for Pauline, right, we added her standing right. So Pauline has a head and she has a bottom. Those actually use 2 different palettes. And her shuffle is the same structure. She has a head. The head doesn't change. The bottom changes. So we toggle between tile 17 and 18. And left is the same as right with the sprite flip bit enabled. And so then we added the Pauline actor and just set her to default values. We set the actual values in code. We added the Pauline actor to the actors list. And we added Pauline the actor Pauline case to the actor accessor, right? So now we can return an address of that actor. And same thing with our new animation. So we've got the 200, 300, 500, 800, and we've got the Pauline standing right, standing left, shuffling right, shuffling left. And that's what we got. So that's good. So we've got corrected sprite tiles. We've got callbacks now on our text or our background blinking functionality. We reworked the background blinking functionality so that it's much more flexible and correct, I think, structurally than what I had done the first time. We have callbacks on that, so now we can tie things to those timers going off. And so Mario can come up here and visit with Pauline. Hi, Pauline. How's it going? Why don't you ever save me from that donkey? He's so mean. All right, so pretty good. We're coming up on an hour and a half. I think that's where I'm going to cut episode 7. So in the next episode, we're going to do even more, right? So we're slowly tying these things together and getting them functioning properly. So the next step will be to get some more actors in here, get Donkey Kong in here, get some barrels in here, and we'll just, keep stacking more and more actors into it. And as we run across functionality in the game engine that is missing, so that we can get all the actors doing what we want them to do, we'll just add it like we did in this episode. So maybe another episode or 2 to get all the actors defined and get them all working properly. And then once we've done that, like I said, we'll go back to the tilemap editor, and we'll actually get the tilemap editor up and running and finished. And we'll define our tile maps, and then we'll work on gameplay. So anyhow, that's it for this one. This is a YouTube only series. So if you like if you like the work, please subscribe. Or like the video, or both. If you have questions or you have areas where you would like to see me cover in more detail, certainly leave a comment. And if you do want to join a Twitch stream at some point, I do Twitch Monday through Saturday from 5 a.m. to 10 a.m. However, May 20th through May 28th, I will be on vacation. So the Twitch stream will resume on May 29th. But at that point, if you want to join a stream, you're welcome to drop by. And those can be fun and entertaining as well. And that'll do it. So thank you very much, and I'll see you in episode 8. And we're getting closer and closer here. Have a good one. Bye.